Math 1332, Chapter 11, Statistics, Section 1, Gathering and Organizing Data, Video 7, Stem and Leaf Plots for Numerical Data. To wrap up this section, we're going to look at one more way to organize and display numerical data. A stem and leaf plot or stem and leaf display is like a grouped frequency distribution. However, instead of creating groups based on class widths and limits, groups are determined by splitting each data point into two parts, a stem and a leaf. The leaf is the last digit in the number, and the stem is the numbers to the left of the leaf. For example, consider the small data set, 81, 92, 97, and 101. In the number 81, the stem is 8 and the leaf is 1. You can literally think of it as taking the number and cutting it into two parts. Stem on the left, leaf on the right. So what would the stem and leaf be for the number 92? In the number 92, the stem is 9 and the leaf is 2. And for 97, in the number 97, the stem is 9 and the leaf is 7. But what about 101? How would we cut that? Because there's actually two places you can cut it, between the 1 and the 0 or between the 0 and the 1. Well, if you were reading and paid attention, you'll see that the leaf is the last digit in the number, meaning that we cut it off between the 0 and the last 1, meaning the stem would be 10 and the leaf would be 1. Spoiler alert, in the number 101, the stem is 10 and the leaf is 1. In general, the leaf is always the last digit and the stem is everything to the left of that. Excuse me. A stem and leaf plot is a two-column table with the columns separated by a single vertical line. The first column contains the stems, each listed only once in order from least to greatest. In the second column, in each row, list the stems for a given leaf from least to greatest. Do not use commas. Just write leaves next to each other. Since each leaf is a single digit, there's no need to distinguish between adjacent leaves. You know me and typos, can't stand to have them lingering around. All right, so why don't we quickly build a stem and leaf display for this 4-element data set. All right, we cleared out that mess. So how would a stem and leaf display look like for this data set? It's pretty easy to draw because there's only 4 numbers. For the first number, 81, we would split it into its leaf, its stem, and its leaf. Now notice that both 92 and 97 have the same stem, but you only list stems once. To indicate 92 and 97, you would simply write the leaves 2 and 7 in that row whose stem is a 9. And for 101, its stem is 10, its leaf is 1, and that's really all there is to it. We're going to take a look at a couple of quick examples. The first one, 29 executives reported the number of telephone calls made during a randomly selected week as shown here. Construct a stem and leaf plot for the data. And if you count them, we have 29 two-digit numbers. Now, sometimes you'll be told how to split a number into a stem and a leaf, but the general rule of thumb is the leaf is always the last digit and the stem is whatever's to the left of that. In this case, these are all two-digit numbers, which means all of them are going to be split right down the middle. Now, it's not uncommon when building a stem and leaf display to have a key. The key basically says what a split means. So in this case, something like 20 means 20. And there's a reason why a key has to be defined, especially if you start with a stem and leaf plot and then deconstruct it, if you will. Now, the problem with building a stem and leaf display is making sure that your leaves are in numerical order. The actual stems themselves are pretty easy because all you have to do is locate, it's supposed to be a line. All you have to do is locate the lowest value and the highest value to determine where your stems begin and end. Scanning across here, it looks like the lowest value is 12. And I see a 39, I see a 40, I see a 50 something. Are there any 60s in here? I don't see any 60s. 59 is the highest number, but in general, the 50s are the highest that this gets. So this goes from the 10s all the way through the 50s. Knowing that the left number on each one of my stems, my lowest stem is 1, and then 2, 3, 4, 5. You should list all stems in between, even if one of them is absent. For example, if there were no 20s in this list, we would still put a stem of 2 so that we don't have any missing stems. There do happen to be some 20s in this list. And then one at a time, we just have to process each number into the stem and leaf plot. Now, the problem with processing the raw data in the order that it's given to you is that your leaves will often not be ordered from least to greatest. We can fix that after we get all the numbers split. For example, the 20, that would put a 0 here. Since the leaf for 20 is 2 and the leaf for 20 is 0, it belongs in the row with its stem, which is 2. 12 would be a 2 in the first row. 39 would be a 9 in the third row, or rather I should say the row whose stem is 3. 38, 41 is the easy part, 43, 51, and you don't have to circle them, but it's easy to lose track of where you are. 52, 59, 55, 53, 59, 50, a lot of 50s, 58, 35, 38, 23, 32, 43. At this point, you're like, okay, I get it, but I got to finish it. 53, 51, 33, 44, 35, 41, 51, 52, 42, and finally 32. At this point, we technically have a stem and leaf display or a stem and leaf plot. We could easily reverse the process and extract all 29 values from this stem and leaf display, especially since we have that key. But there are some people that will say a stem and leaf plot is not complete until the leaves in each row are arranged from least to greatest. And it's not impossible to process your raw data and put the leaves in order at the same time. The only problem is you don't know how much space you're going to need between leaves for future leaves to land in the correct location. So sometimes it's easier to just make the stem and leaf display without putting the leaves in order, then going through and cleaning it up. For example, the first row, there's just one leaf, so nothing to worry about there. In the second row, the leaves are in order, so we're good. But in subsequent rows, we're not so lucky. For example, in this row, if we were to put them in order from least to greatest, it would be 2, 2, 3, no 4s, couple of 5s, no 6s, no 7s, a couple of 8s, and a 9. And through the miracle of technology, I can just get rid of all these, grab all this, and move it on over. And then we'll do the same thing for the remaining rows. And the row whose stem is 4, our leaves from least to greatest look like they are 1, 1, 2, 3, 3, 4. Let's make sure. 1, 1, 2, 3, 3, 4. That is correct. So let's get rid of this. And let's grab these, move them over. And then finally, this last one's going to take a little bit more time, but it's nothing we can't handle. If we put these in order, it's going to start with a 0. There are 1, 2, 3 1s. There are 2 2s. There are 2 3s. No 4s, there's a 5. No 6s or 7s, there's an 8. And there's 2 9s. So it took a little more work to get those in order, but you're being asked to put numbers in order. There are much worse things you can be asked to do in a math class. And that would complete the stem and leaf display for this data set. We're going to take a look at one more, but this one's already been created to illustrate the need for a key. For example, let's say that you haven't read what I'm covering up right now. And I asked you to extract the data set from the stem and leaf plot. Your inclination will probably be to build a bunch of two-digit numbers because that's what we just did with a bunch of two-digit numbers, turn them into a stem and leaf display. For example, this 1 coupled with that stem, you might think is a 21. But what if I told you it wasn't? What if I told you that the key is 3 as a stem and 2 as a leaf means the number 3.2? These weren't two-digit numbers. These were numbers with 1 decimal place. Without the key, there's really no way to know that. So it's kind of important to have a key, especially if you already have a stem and leaf display and you expect somebody to know what the data set originally was. But let's extract the data from this data set. We'll open up a set and we'll just go left to right, starting with the first leaf. First leaf is 1, its stem is 0, and according to the key, that is 0.1. Continuing along the first row, the next leaf would be 0.1. The next leaf means 0.3, followed by 0.5 and 0.6. All of these are the leaves on the first row, and according to the key, these are the 5 numbers they represent. If we move to the next row, this 0 as a leaf in the row whose stem is 1 would mean 1.0, and then continuing down that row of leaves, 1.5, 1.6, and 1.9. Moving to the last row, whose stem is 2, the first leaf is 1, so according to the key, that would represent 2.1, and then continuing 2.1, 2.1, 2.7, and 2.9. But without the key, those would have all been two-digit numbers. Well, the first 5 would have been one-digit numbers, 1, 1, 3, 5, and 6. But that's why it's important to have a key, especially when you're undoing a stem and leaf display.